The robot gets a perfect score, 100%.
Looks great, right? But the moment new examples show up, it falls apart. So, did it learn or did it memorize?
Now we change the world. New cards slide onto the board. The old shortcut stops working.
The robot suddenly looks lost. That is why we need a real test.
Let's make it easier to see. Imagine the robot is learning flowers. Some flowers are red, some are blue, some are yellow. The goal is not to copy one picture. It has to learn what makes a flower a flower.
Here is the mistake.
The model may focus only on color. That works for the practice flowers.
Then a new flower breaks the shortcut.
Color alone was never the real rule. So we give it better clues. Petals matter. Leaves matter. Shape matters too. Now the rule can work on new flowers. Now we go back to training. The robot practices on examples it already knows. Each card enters the learning loop. The score goes up with practice. But practice is only the first step. Next, we bring in new examples. These cards were not in training. They come from outside the familiar set. This is where the model gets tested. It has to handle what it has not seen. And here is the first problem. Training looked strong.
The robot felt confident. But the test cards tell a different story. Good practice is not always good learning. So what should it learn? Not every tiny dot. Not every random detail.
It should find the pattern underneath. That is what real learning means. This model is too simple. It draws one stiff line. A lot of points get missed. The gaps show the error. This is underfitting. A better fit finds the middle. The curve follows the main trend. It does not chase every tiny mistake. The checks start to pass. This is closer to what we want. But there is a knob to watch. If the model is too stiff, it misses the shape. If it is balanced, it learns the trend. If it gets too flexible, risk goes up.
Too much freedom can become a trap. Overfitting starts quietly. At first, the curve looks useful. Then it starts hugging every point.
The training score keeps climbing, but the model is learning accidents. This is why overfitting happens. The model has too much freedom. It tries to explain every bump. That feels accurate on training data, but the rule becomes fragile. Some bumps are just noise. They shake around the real pattern. The signal is calmer. The model should follow the signal, not the distraction.
Noise makes the trap even worse. Random points can look important. The model wants to explain them all. But noise is not a real pattern. We need to ignore it.
Now compare two kinds of learning. Memorization stores exact examples. The cards go into the drawers. The same cards can come back out. But that is not the same as understanding. Understanding works differently. Many examples enter the funnel. The details compress into a rule.
The light turns on. A rule can work beyond the original cards.
Now watch the trade-off. Training error goes down.
That sounds good at first, but test error can rise. The scale is warning us.
This is where validation helps. It acts like a checkpoint. A useful rule can pass through. A memorized curve gets blocked. The gate tests the idea early. Detection starts with 2 scores. Training may keep improving. Validation may stop improving.
When the gap opens, pay attention. That gap is the warning sign. The warning is now clear. Training still looks strong. Validation is falling behind. The alarm turns on. This is the moment to fix the model.
Now we open the toolbox. Each tool helps in a different way. More data can help. Regularization can calm the curve. Simpler models and stopping can help too. First, add more data. New examples fill the empty space. The pattern becomes easier to see. The model has fewer shortcuts to hide behind. More diverse data makes learning stronger. Here is that fix in action. More examples enter the chart. The cloud becomes denser. The trend gets clearer. The shortcut becomes harder to use. Another tool is regularization. Think of it like a spring. It pulls wild curves back. Extra wiggles lose strength. The model becomes safer. Here is the spring at work. The curve wants to wiggle. The spring adds resistance. The useful shape stays. The wild motion fades. Sometimes the model is just too complex. The curve has too many loops. The scissors cut the extra wiggles. The simpler model appears. The trend is still there. Now we simplify on purpose. The extra loops get removed. The clutter falls away. The useful branch stays. Keep the trend, not the mess. There is one more tool. Training runs over time. At first, validation improves.
Then the red zone begins.
Stop before overfitting takes over. So the full strategy is simple. Use better data. Control flexibility. Keep the model simple when needed. Then test it on examples it has never seen.
Now the final test arrives. These examples were never seen before. The model handles them well.
That is generalization. Real learning works beyond practice.